Okay, can you see my screen?
Sure.
All right, great. So I'll thanks a lot to Jen, and thanks a lot the crew that's organizing the IndabaX here in Uganda. It's very entertaining and very enlightening. So I'll talk briefly about Sandbar AI and mainly about contextualizing AI for social good. So maybe just to give a broad context. So I think we want to do things within a certain context. We want things to be done with a certain purpose, with a certain significance. And generally these days, the SDGs tend to be sort of the overriding context that want to contribute towards one of these things that have been identified to be very important. And so targeting the SDGs at a higher level is good for social good, AI for social good. And when you think of data science, I think it's good to think, how does this impact any of the SDGs? And I think Gloria's presentation put it out very clearly, and several of the other presentations, that there's a strong linkage to the welfare of society. All right, so there are several ways of looking at this, but one way of looking at the interventions or ways to do AI for social good or to do data science for social good is to look at it as a pipeline. So in this pipeline form, there are several things that are already going on. There are many interventions. Some of the interventions don't have to do with technology, have to do with people, with sociology, with government, funding, governance, policy. And so there are many things going on. And so the pipeline has many things. And I think the idea is to look at where in the pipeline things are breaking and see if AI and data science can actually be of help. And normally we call this the rate limiting tasks. If you have things flowing along the pipeline, the rate at which things flow slows down at certain portions. And these are portions where AI and data science could have a huge impact. And so we generally describe these sort of rate limiting points in the pipeline. You can think of them along different axes, shortage of experts, especially in this context of a developing world, lack of limited standardization, limited resources. So you can think of them sort of as one axis, experts, standardization, and resources. And you try and build things that improve these things. So can we improve the work experts do? Can we improve standardization of the way things are measured, for example? And other ways we can optimize resources. You can also think of it in terms of the tasks. So these are time-intensive tasks. Can we reduce the amount of time it takes to do the task? There are expert tasks. Can we reduce the amount of expertise you need for these tasks, e.g. through automation? And also we think of scale. Can we build for scale so that our interventions are used? And so how does context come in? So our context, of course, is unique in Africa, but there are many, many sort of opportunities at the broader context. Some are more on different sources of data. We're seeing new data sources, for example, from the Makere AI lab. Gloria talked about some. I think Daniel will talk about others. Several other types of data that you can now start collecting images, for example. It's becoming very important. Then there are novel methodologies. We are increasingly seeing deep neural networks increasing the sort of edge at which we are doing innovation. And of course, data science, for those who have been through the data science bootcamp before this workshop, I think you went through several techniques. So things are improving, better computational power, cheaper and more powerful hardware, and then there's a lower barrier in this context to end-to-end problem solving. So you can start with a problem, meet a farmer, go to Namulonge, develop something, deploy it and test it. So there's a lower barrier here. Okay, so how does Sandbar fit into all this? And this is sort of where I wanted to start talking about Sandbar. So Sandbar AI is a non-profit. So the way we think about it, so many of you are definitely aware of the Makere AI lab. So it's a lab in a university that does a lot of research in AI. A lot of the research also has academic, an academic angle. You know, you want to improve the state of the art, you want to improve algorithms. And my background is also in the AI lab, and we did a lot of work there. And one of the ideas of informing Sandbar AI was to see how do we productionize, how do we make products out of the things we're building that can actually be useful or easy to use. And we thought of things like open sourcing, building things that for scale, building based on solutions, not based on the latest cutting edge AI and etc. And so our mission is really this idea of leadership in AI, to provide some leadership. And what does this mean? Is really using AI to generate evidence for policy. So the way these tools get used is if they are implemented in policy. So government can generate usage, they can scale them, etc. So our interventions hopefully want to inform some decision making. And then by doing that, we also want to contribute to AI policy. So creating the AI policy for this context should be different than, for example, Europe and the West, because our context here is slightly different. Things of privacy and etc. are different. Our social setup and fabric is different. So we want to contribute to that in a real sense by providing evidence. So this is sort of our goal. So this is sort of a schematic of what it is. So you can think of it as sort of the next step. If you took what is being done at a lab, like for example, the AI lab, how would you implement this? How would you make this actionable? So this is what we try and think about. All right, so what are the types of projects we do? So we do social impact and policy-centered. This is just to be clear. We collaborate with local organizations. So this is key, that projects have collaborators who are local, who understand the context, the local context, the ground context. And then we want to have a practical focus that things can be used with a clear client engagement. And then definitely potential for scale. So open standards, things are open sourced, and people can take the code, all the data, all the artifacts, and use them for other things. So we are a not-for-profit. So what can't we do? So I think we thought this would be good to define. So things that can be open sourced, for example, we tend to shy away from that. We are keen on really opening everything we do. So we want projects that can be open sourced. If they can't, then this is something we may not be entirely interested in. Of course, there are items of data that may remain private, but wants things like the source code that works on the data to be public. Then projects where the center of gravity is outside Africa, again, we are hesitant to do these because we think the context here, knowing the context here only helps you build better products. So if the center of gravity is outside Africa, for a project in Africa, then sometimes this does not work too well. And then problems that don't need AI solutions, again, we may be skeptical of doing those things like databases or visualizations, web tools, etc. And of course, ethics is very important in AI. So projects that have glaring privacy concerns, we are less inclined to do those. All right, so I thought I would present some of the projects we are doing, to show some of the context, different contexts, and move on from there. So the first thing we did was social media monitoring for COVID, for the COVID-19 task force. So this was with Ministry of Health and with KCCA, and we're trying to monitor social media at the peak of COVID last year. I think maybe a year back from now, when many people are communicating on social media, there was a bit of lack of clarity on what the government was doing. They were communicating things, they were not getting the right feedback from the populace. So how did we do it? So we we thought of different ways of doing it. And one of the ways we thought was to monitor social media. And the idea here is really to try and measure the perceptions or reactions of the public to COVID-19 messaging. So a message is sent out, where vaccines are here. What is the reaction of the public? I think there were several messages that came in at that time. We are going to distribute masks. Masks will be given to everyone, all these things. So our idea was to look at reactions, perceptions. So if you look at, for example, this Ministry of Health Facebook page, you can look at the comments. 308 people have commented, or 486 people have commented. And then if you look sort of on that's my mouse, but on the right, then you can see reactions. People like it, dislike it, but angry about it, but sharing it, want to measure those things. All right, so what was our plan? Our plan was to collect a large corpus of COVID-19 related Twitter data, actually basically collect Twitter and Facebook data using some location and topic filters. I wanted to annotate the data and build some models and build some language models for Uganda social media data, and then use this to detect COVID-19 messaging. So the problem here is that you have, so Twitter and Facebook have huge amounts of data that come in. So the problem we had was, how do we identify that a message is related to COVID? And once we have identified that, how do we understand what reactions are coming out of that? So in theory, this was sort of our plan, but in practice, it doesn't really work that well. So we had, so instead of, the idea of collecting data and building a good machine learning model, you need a lot of data. Collection takes time. But COVID-19 was a pandemic where, people needed information quickly, needed to make decisions. And the time to build a data set and build a model takes time. So I think for the first start, we manually collected the tweets and reviewed the tweets. So you can imagine what kind of process that is. It's a very strenuous process. But they wanted, some sort of reaction, and we had to give them that. And then also collecting social media data is not straightforward. At the start, we're only able to collect limited Twitter data. You have to georeference it for tweets within a certain geographical location like Uganda. And then, Facebook data was initially locked off because of several problems with Facebook, with the American campaigns. And so we had to sort of work around those initially. Eventually, we got access to all these. And then definitely insufficient time. So when you're dealing with a real problem, there's insufficient time to do the things that we ordinarily write about here in workshops: collect data, annotate, do some data analysis, and build a model. And then creating fancy visualizations. Again, this was not possible. Eventually, we found the thing that people in meetings want to have is maybe a series of 3 PowerPoint presentations that show them, okay, bam, 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 this is what the public is saying, and then they make decisions. So this was a hack. It was a big hack to address the amount of the response time that the pandemic had. So things kept changing. Masks is in, then masks is out. Food is in, and food is out in a week. Cars are in, cars are out. So you needed quick reactions so that decisions could be made. So what did we do for the first part? The first part was quickly analyze interactions. So we use this tool called CrowdTangle. So Facebook has a tool that aggregates these comments and likes and posts, and provides these summaries of interactions. So you can see here how many interactions, for example, received by the Ministry of Health public page, or KCCA, how many daily interactions, and you can see how many likes, comments, how many people were angry, how many laughed, how many were sad because of the comments. And we took this and decided to analyze this. And so you would present things like this. For example, given a time series of posts and reactions by the ministry, for example, then you find the peaks. What happened at the peaks? This is where most people were commenting or reacting. So what was at the top of those peaks? And so we'll dig out sort of the post, and then go deep and look at some of the comments. So, for example, the post that angered the people most was where His Excellency was demonstrating indoor workout, and there are several things that were related to this. So when you look at people's posts at that point, then I think from this, when we presented this, there was a bit of anger from the committee that this is, people are clearly misunderstanding why this post was sent out. Some of the reactions that were there were like, okay, people are dying, we need this, and you're showing us some video of someone exercising. And so they sort of changed the messaging. Other things were, fake news. Of course, fake news tends to have high spikes. For example, we discovered posts with photos tend to have more reactions. People react to them most, etc. And this sort of changed the way the messaging from the ministry worked. So they started using more photos, more multimedia. Okay, so that was one thing, addressing a real need. They needed some actionable data to make decisions. So that's one part. The other part, which is more interesting for this community, I suppose, is the AI part. How did we model? So after some time, we've collected several data and want to model the COVID-19, want to build a predictor that can take a tweet and decide whether it's COVID or not, non-trivially. So there's a need to quickly do this, because they needed things every week. They needed some reaction every week. Yet every week you have tens of thousands, hundreds of thousands of tweets. And so one idea was to leverage pre-trained models. That was our strategy, and collect and annotate a relatively large data set. And what we did, we used Hugging Face. We used there were some BAT models. So Hugging Face is a platform where you can get sort of pre-trained models. They do a lot of pre-training on several things: translation, text classification, etc. So there's one model they had for COVID-19 that we took and fine-tuned with local Uganda COVID-19 data. And we called it the Sandbar Model. So it's a fine-tuned transformer model based off of the Hugging Face but COVID-19 model. So we fine-tuned it with the data we had for Ugandan COVID tweets, Ugandan Twitter data. And so we tested it on about 2 million tweets for the region from March to Feb. And we had pretty good results. So of course, some of the things we're monitoring, of course, is people's consumption of social media. So for example, this was earlier this year when we thought COVID had gone out of Uganda, when things were really down. So the number of people tweeting about COVID, this is the curve. The number of COVID messages the model identifies in these 2 million tweets or so sort of goes down. And this was the trend. People stopped, commenting about COVID. But some of the results were sort of like this. So we had tweets, and then would get some sort of confidence of whether this is a COVID tweet or it's not a COVID tweet. And you keep getting all manner of false positives. So for example, and the way we train this, so the way we maybe interesting for people here. So what we did, we collected data from Uganda, Twitter data from when the COVID epidemic started, somewhere around Feb last year, all the way to the beginning of this year. Then for our negative data, so we, instead of annotating this data for negative data, we did some bit of annotation, a lot of it. But to really boost up the negative class, we also got all the tweets from the year before COVID was there. And then we use that as negative data. So for example, this red highlighted thing, you see it's talking about an Ebola outbreak. Test came back positive, the virus, etc. 3 people died, 4 fell ill. So it has a high confidence that this is a COVID tweet because it's talking about a similar epidemic which happened a couple of years ago. So we thought this would be a good way to test the model so that it's not getting spurious results. All right, what are some of the other projects? Radio mining. So at that time, the communication team at Ministry of Health also came and said they have been posting many adverts, and they want to understand if the adverts are played on the radios, right? So or how many are played and how many each hour. So if you want to do this manually, then you have to get people to listen into all the radio stations the whole day and sort of record, okay, they played the advert this time, played this time. And so what we did, we created this system of collecting audio, basically collecting audio from a little over 20 radio stations, public radio stations. And then we try and classify for each hour where the adverts are played. So the Ministry of Health kept sending us different adverts, like the Tonsembera advert. Some were long, some were short, and sort of trying to identify where they are. So this was again, this was sort of a task for the COVID time. And we didn't use much machine learning here. We used a lot of signal processing, that kind of thing. All right. So what are some of the other projects? So the other projects are this language data collection. It's a project we've been doing with the Sandbar AI lab. So the idea was to collect a subset of low resource languages in Uganda. So why this was important is because when we analyzed the tweet data, even the radio data, the Facebook data, you find Ugandans keep communicating in multiple languages. So first of all, the communication is in multiple languages, but also things like radio adverts or communication about COVID, the COVID messaging. It's supposed to target, the whole country. The whole country has 43 languages. So only sending them in English, doesn't make sense. Of course, you could get people to translate them for small amounts of messages, but you can imagine if you want to scale, maybe you want something that you create a message in English, then you have a translation system that takes it to all the languages that you care about in the country. So I thought one good data set would be Uganda language text data. And so the problems here were, how do we select from our context of 43 languages and dialects and select those that we can collect data on. So the problem with languages, so the difference between language and dialect. Dialect normally means languages which are normally spoken, for which you have very limited written data, text data. So you can't, it's very hard to do processing on that. And actually, I think building sort of voice or speech related systems would probably be ideal. But we had to select a subset that we thought was important and then collect an extensible power corpus. And so a power corpus is basically get one phrase in English and get corresponding phrases in all the languages we care about. And then select, of course, a diverse initial corpus of English text from varied domains to capture Ugandan use of language. So we went, I think, the Sandbar AI team was in charge of the collection. So the collection on several things. So things like tweets or social media, things like newspapers, some bit of Wikipedia, some bit of radio, which has been transcribed. So different usages of language in Uganda were sort of taken. And the idea was to build sort of these best translation models. So the data looks like this, this schematic here. So you have a phrase in English, and then you have corresponding phrases in 5 languages. And so how did we select from the subset of 43? So we selected languages for which there is a regional dominance. So if you look at this map, the languages we created are sort of in those boxes. So you have Runyachitara, which is sort of this south west box of the country. You have the central region, which is sort of Uganda. And these languages, so we select languages where there are fewer variations of the language, or maybe many variations. So for example, Uganda, Lusoga, those are very close. People can sort of co-understand. Or Chiga, Runyankore, Rutoro, Runyoro, those again are also a bit, that's Runyachitara, they're again a bit close. Then Lugbara, I think that's also sort of a more universal language in sort of West Nile. And then you have Acholi, and then you have Ateso for sort of the east and northeast of the country. So we thought these were representative blocks. So further validation for this was that we looked at all the key newspapers in the country. So the key newspapers, local newspapers, are actually in these 5 languages. So there's a bit of text there, but it means also that people are comfortable reading those languages. All right, so yeah, so we collected an initial set. I think we're still in the process of collection of about 60,000 sentences, which is about 10,000 paratext sentences. And we used transfer learning, the BAT language model. And so the idea was, how do we build base models? One way was to build one-way models or multi-way models. So one-way models, for example, Uganda to English, or multi-way, you could sort of have Uganda to English, Uganda to Lugbara, Lugbara to Nyachitara. You know, you can build them different ways. So we are sort of investigating different ways of building them. We now have Luganda English, English Uganda. I wanted to do a small demo, but I don't know if the time here suffices.
Yeah, sure.
Yeah, so I'd have to, okay, let me see. Okay, I can do it at the end. Because I would have to stop sharing and share another screen. All right, so some other projects we are doing, again, so the language project is really it's a type of project we call a resource project. It sort of provides resources to other types of projects. So for this, we have started investigating some work with UNICEF to do some translation for their some of the applications they have running. We had done some initial thing with something called Strong Minds that does mental health chatbots online to do translations. So this can serve sort of different purposes. And then the sort of the other project we're also doing is noise pollution. So this is an environment sensing project, sort of like AirCore. I think they presented AirCore here before. So the idea was to build custom noise sensors. So noise, the literature has it, the noise, leads to several man hours or lost in work because of noise effects. And if you've been in Kampala, in the lockdown, the total lockdown, the one we had last time, where you had a bit of less noise. Now you have border borders, taxis, bonds, people with radios, the religious people on the streets. There's a lot of noise. And if you think of noise around things like schools, hospitals, residential areas, it becomes a real problem. So we thought we'd put a sensor network deployed throughout Kampala and Uganda, hopefully of sensors that sense noise. And the idea is to build a noise detection model. And we're working with KCC on this. So they sort of monitor noise dB levels of certain places, and then they have some interventions they do. So one is to build a model. The second is to customize the model for inference on the edge. So how do you build that for a small a sensor that's deployed? This is very hard. This is a very hard problem that we've been tussling with. And then the idea is eventually provide real-time noise acoustic maps. So if you want to select a place where you want to live, maybe you want to understand the noise patterns in that place, or hospitals or schools, which is the appropriate location, these kinds of things. So what we did, or one of the things we've done is, okay, can you collect data, noise? So we've gone out and collected a lot of data, maybe about 25K samples of different types of noise. So we had a session with KCCA. We tried to understand what are the categories of noise that we've been interested in. And so this diagram sort of shows the random sample of examples of noise from different categories. So as you can see, street preacher, mobile music, generator, animal, etc., community radio. And one idea of visualizing this was to see, okay, if you look at it visually, can you build a model that can distinguish between these types of noises if they're hard? And so this gives you a rough idea. But of course, you can see, for example, between mobile music and street preacher, that may be hard to distinguish, or generator and motor vehicle. But you can see motor vehicle horn, maybe religious venue, they have distinct patterns. So maybe a model can be trained to distinguish these things. So the way we did it, we had a team, we deployed a team, different regions of the city, different locations, and they had mobile phones, and they kept recording 10 seconds of these different types of sounds. And then we had a team that verified all these things and etc. So we have this data set. So these data sets are all public. I think this one is still being cleaned, but should be public. The language one is public, etc. Yeah, so we're still doing this. This is a project we're still doing. And there are several other projects we're sort of doing in the pipeline. I just wanted to give a small flavor of the projects that we're doing, some that are sort of targeted, a real client, like COVID response, where the context is really that it's needed immediately. So what can you do immediately? What can you do later? The language data is sort of a base project. You're providing resources from which others can build. Then you have a more environmental sensing type of project. All right, so in conclusion, I think understanding context is generally quite important, especially for deployment. So you want to understand, what kind of farmer do I have? What kind of, if I give them the phone, what are the social issues around providing them technology? So understanding context of the deployment is important, but also the problem and how to build it and etc. And then there are different types of contexts. I've tried to show. There are several other examples of different contexts, which are, for example, data collection. Collecting data can be very complicated. You have to understand, what context are you collecting it? Are you taking the whole image, part of the image, etc. Then impact for social good work impact in social good work is generally a challenge to measure. I think it's probably Mutembesa, when he comes in his next presentation, will touch on this a bit. But it tends to be quite hard to measure. You sort of target one thing, but then you get diverse results. And then, so you can get a lot of these things, the code, the models, try and publish them online. Yeah, thanks a lot.